Anatomy Sis. This is Mystery and the Halloween edition. Woohoo! To Notes in Anatomy. All right. Yeah, so much for that. Way too hot. All right. Little thriller in the background. All right. Kind of spice things up a little bit. Maybe not. All right. So let's talk a little bit about muscles. So this is the new chapter. This will be our last chapter of this trimester. Woohoo! Then we'll pick back up third try and go into the brain and some other things. And the good news is, if you take my next try, there's a lot more hands-on, a lot more dissection, and I'll show you a lot about the eye and the heart and all those good things. All right. Hopefully COVID's getting out of here one of these days. All right. So anatomy notes chapter 10 and 11 are on the muscles. So a little introduction, about 40 to 50% of your body weight is skeletal muscles. Little review from the tissue chapter, histology. We went over this. I said we'd be coming back. Here it is. There are three types of muscles: skeletal, visceral, and cardiac. Skeletal is, your biceps, your triceps, all the 600 plus muscles that move us every single day. We have control over them. They're striated, which means they have lines in them. I'll show you pictures in a second. And they're muscle that attaches to bone, muscle tissue that attaches to bone. Visceral is non-striated or smooth. We do not have control over this, which is fine. We wouldn't want to. Your stomach, the hollow walls of your blood vessels, your intestine, places like that. A lot of times we just call that smooth muscle. And then cardiac is obviously your heart, striated and involuntary. So that's the three types of tissues. If you look at them under the microscope, which we did, this has been a little while ago, but we did look at these, when we were going over the tissue chapter. This is skeletal muscle. You can see the lines in there, the striations. This is smooth, no lines. Okay, that'd be inside your intestine. And then this is cardiac, and you see all the little dark spots. That's mitochondria, because we require so much mitochondria because your heart has to beat 24/7 your entire lifetime. All right. So we mainly want to focus in. I got heart coming up later. I got visceral coming up in the digestive chapter, a second try. So we're not going to spend much time on those two. We're going to focus on the skeletal muscles, and I put on there today some collar sheets, lots of collar sheets that kind of go through the major muscles. Obviously, we're not going to go over 600 plus, but we will go over some of the major groups that will, so you'll get to know how you move, okay? I just kind of wanted to go over a little bit today. I don't know if we'll get through all this, maybe a couple more slides. I'd like to get through maybe 3 slides, maybe 4. We may go a little extra because we're running out of days here. I only got 7 days left after break. So some general things. What are 3 things that muscles do? Movement is obvious. Skeletal muscles shorten and lengthen and allow us to move our arms and our legs and our whole body. Heat production, we don't think about that. It's called catabolism. That's what maintains our body temperature and keeps us maintaining homeostasis. Very, very important. So, we don't use much of the energy for muscle movement. It's pretty sad. Most of it we lose out as heat. We trap a little bit of that to maintain our body temp. Okay, and posture, being able to have some partial contractions that allow us to stand, sit, and do the things we do on a daily basis as well. Okay, some facts about muscles. Muscles only contract as stimulated. And there's a lot of different types. We'll go through some of that as we kind of get through or go through that. And the greatest strength principle is the big thing. What's confusing about muscle contraction, and I'll talk more about this later too, the confusing part is that when muscles fire, they fire all or nothing, okay? But yet, if I'm picking up a piece of paper or I'm picking up a big 50-pound weight, I want to be able to control. I don't want my muscle to go full force if I'm picking up a piece of paper. So what our body does, which this will make sense hopefully, it's called the greatest strength principle. We only turn on a few fibers to pick up a piece of paper, but we turn on all of them to pick up a heavy weight. And sometimes in extreme conditions, I got a video that shows this. Maybe I'll show it to you later. You actually can fire all your muscles at the same time. Only under extreme situations. You hear of people lifting a car off of someone. I got a video of a guy throwing a ton rock off of him, which you shouldn't be able to do. But if you can make all of your muscle fibers do fire at the same time, you can do extraordinary things. But we only do that under extreme conditions. So that's something that we will talk a lot about as we kind of go through notes here. Okay. Well, let me show you this video real quick. I know we'll probably get a little bit of a echo in there, but let's try this. So give me a second. If it'll load, it may not load. If it doesn't, that's okay. So that's kind of how my technology has been going today. I don't know what's going on here at school, but it seems like it's going really slow. So let me get this out of the way here. Here we go. I don't know what's going on. Let's forget that. Anyway, here we go. Sorry for the echo.
Survives to the human skeleton's extraordinary resilience.
But when we consciously want to test our strength, our muscles and bones collaborate to give us maximum power. The human body has resources far beyond what we can imagine. In a true test of muscles, how does the body's ultimate strength measure up? How far can we go when life hangs in the balance? We each have incredible strength inside, far more than we know. A normal person can move as much as this guy, but only in a crisis.
It's a little steep here.
Pinned beneath a 1,200-pound rock, sliding toward a cliff and certain death, a climber finds power in his muscles far beyond normal limits. The Sandia Mountains in New Mexico test many climbers. Their granite faces are notoriously unstable.
It's a little steep here.
Mark was in front, and I lost my footing just a little. And by instinct to catch myself, I reached over and put my hands on the wall. And that's when all hell broke loose. The wall essentially came up in my hands. This thing was huge. And how it could crush him to death, I don't know, but I just watched him, and I couldn't believe he was actually still alive.
The rock slab has trapped Sandia. It could crush his ribs, but with his arm muscles, he's able to hold it off. But only just. He's on sloping ledge. He's sliding toward a high cliff and doom. He's stunned and in shock, but his body has gone into overdrive. St. John's survival depends on what's locked in the muscles of his arms, chest, and shoulders. But how can mere muscles move something that massive? Muscle tissue works.
Okay, so I just want to show you a little bit of that. And he literally threw 1,200-pound rock off of himself as he's sliding, off a cliff, which is just crazy when you think about it. But that's something that I think that people need to understand. Under extreme situation, and we can't physically just say in our brain, oh, I want to lift this heavy weight, I'm going to do it. Adrenaline, survival mode has to kick in. But you can do these extraordinary feats if you can fire all your muscles at once. But most of the time we don't. Most of the time we just fire a small group of muscles to do everyday activities, and that way we conserve energy and we don't harm ourselves and that type of thing. So there's basically 4 factors that determine how strong a contraction is: the initial length of fiber, stretching. The more you stretch a muscle, the stronger it contracts. Coaches a lot of times in sports will have their athletes stretch, and most of the time we're stretching to prevent injuries, but a lot of people don't realize that if you stretch those muscles and you warm them up, they'll actually perform better than a cold non-stretch muscle. So it has a dual purpose: prevents injuries, number one; number two, they perform at a more maximum level. Okay. Metabolic conditions, pretty obvious: food and oxygen. If you have deficient amounts of either one of them, you're not going to do well. That's when your muscles turn to rubber. If you exercise for a long time and you have oxygen debt, you start gasping for air. Because if you don't have enough oxygen in your body and you use up a lot of it, instead of getting 38 ATP, you only get 2. And you get this nasty stuff called lactic acid, which causes muscle fatigue and causes you to have oxygen debt. So metabolic conditions is really important. That's why a lot of times coaches will have their athletes carbo load before an athletic event, eat pasta or whatever 24 hours before, because that helps have more food and better, longer endurance, which is a good idea. Okay. Number of fibers is the big one. Okay. Obviously, the more fibers you stimulate, the more it's going to contract. So that's how we control the strength of a contraction. How many fibers do we turn on? Okay. And load, this is weightlifting. If you increase load, you're going to have stronger contractions, and over time you can build muscle mass and perform better. So that's the idea behind weightlifting and training and getting stronger for athletic sports. Okay. A couple other things. When skeletal muscles move, there's a little physics involved. They produce movements by pulling on bones. Usually muscles span at least one joint. And usually don't lie over that joint. When a muscle contracts, the muscle shortens and both bones get pulled. So you move your arm, you move your legs, you do whatever. The reason both of those do not move is due to what we call isometric contractions. We'll talk more about this later. But we have some partial contractions that help stabilize, so we're just not having our arms and legs fly all over the place. Okay. Muscles or bones serve as the levers, and joints are the fulcrums. Muscles produce the force. So you have to have a combination of joints, skeletal, bones, and the muscle itself. Okay. And usually the muscle doesn't move over the part that we're moving, because if it did, then obviously it would get in the way. Okay. Really, really important that we understand how those work. Okay. And the last thing, and then we're going to call it quits for today, is skeletal muscles always act as a group. Prime movers are the ones that contract and produce the movement. What happened to me there? That's okay. Antagonists are prime movers contract at the same time well, let's put it this way. Think of English class, right? So an antagonist is the villain, right? The person that's causing problems, right? So we have groups of muscles. When a prime mover is the main muscle moving, the antagonist is the opposite. So when the prime mover contracts, so I'm moving my arm, then the tricep has to relax for me to move my arm. So my bicep becomes the prime mover, my tricep becomes the antagonist. But when I drop my arm and extend it, now my tricep becomes the prime mover and my bicep becomes the antagonist. So they switch roles depending on what movement we do. Now remember, think how fast we have to do this if we're running and sprinting. It's crazy. The only exception in the body where we have a prime mover and antagonist that contract at the same time is your knee. And that's what holds your body rigid, and that's how we can stand. That's also why they tell you if you're standing at attention for a long time, like a marching band or a soldier at Buckingham Palace or whatever. I got some videos I will post later you can watch. You can pass out because it cuts the blood supply off to your brain. So you got to be careful with that. But that's the only exception. Most of the time, a prime mover contracts and the antagonist relaxes. A synergist are muscles that contract at the same time, and they help stabilize a part. So these have to all work together to produce these smooth, coordinated movements and allow us not to be jerking all over the place. Okay. And here's the last thing for today, and we're done. But 80% of the energy that we produce during muscle movement, we lose as heat. We trap a little bit of that, but not all of it. All right. And that's the bell because my class is getting ready to start. So there you go. So we are done with notes. Hey, have a good day.